In this video, I'm going to talk to you about Section 3. Section 3 is about intersecting lines. In the rest of Chapter 9, until now, we talked about solving equations. And when we look at intersecting lines, you need to be able to solve equations. But before we do that, we're going to look at plotting the graphs of two linear formulas, and we're going to look at the point of intersection. So first, we're going to look at two linear formulas, and we're going to plot the graphs of both formulas in one coordinate system. So, when I look at this formula, y is equal to 2x minus 7. I'm going to use my table first, so it's more easy to plot the graphs. So what's really important is to think about Chapter 1, and that's a long time ago. When you look at the linear formula, we always have two numbers, minus 7 and 2. This minus 7, it's the number without a variable. That's always y-intercept. So this is y-intercept. And then when you know this, you can immediately fill this in below x is 0. And you can also calculate this. 2 times 0, that's 0. Minus 7 is minus 7. So y-intercept, you can always find it with your 0, x is 0. So then there's the second number, and that's gradient. Gradient. That means the gradient's always with a variable. Well, you can easily use this when you have to fill in a table, because this means when x is 1 more, y is 2 more. Please remember, 1 to the right and y goes 2 up. So this will be minus 5. And you can also calculate this. 2 times 1 is 2. 2 minus 7 is minus 5. But please remember, we go 1 to the right, 2 up. So this is minus 3. 1 to the right, 2 up. This is a really easy way to fill in your table. It's really quick. Yes? Okay. Then we're going to make the second table. And again, we look at y-intercept. And y-intercept always belongs to x is 0. Y-intercept over here is positive 18. So we can fill this in below 0. Again, you can calculate this. Minus 3 times 0 is 0. Plus 18 is 18. So then we look at gradient. And in this formula, gradient is minus 3. And this means 1 to the right, 3 down, because it's minus 3. 1 to the right, and then we go 3 down. So 18 minus 3 is 15. 1 to the right, and we go minus 3. 1 to the right, minus 3. And again, when you know this, you can fill in a table really quickly. So, and now I'm able to plot both graphs in one coordinate system. For this exercise, we take the horizontal and the vertical axis from 0 to 10, and we use steps of 1. It's not a problem if some of these results, you will see that some of these results we're not able to plot in this coordinate system, but that is not a problem. So take some time to draw the coordinate system, and then you're going to plot your graphs. You should end up with this, and you see some of the results in our table are not in my coordinate system, but that's not a problem, because this section is really about the point of intersection. Both graphs are different, but there's just one point of intersection, and that's over here. And this is what this section is all about this point. Because what are the coordinates of the point of intersection of the graphs? And that is this point. And please look carefully. First we look at the horizontal axis, the x-axis. and the coordinate is 5. And with that, there is a y coordinate, and that's 3. So make sure when you write down coordinates that they need to be between brackets. So the point of intersection has these coordinates, 5, 3. So that's our point of intersection. Yes? Okay. We already saw that the point of intersection of the graphs was 5, 3. Well, now we are going to fill in the x value in both formulas, and we're going to check if our answer is correct. When you're going to do that, you need to know that the first number always belongs to x, and the second number always belongs to y. So what I'm going to do is I'm going to fill in this 5 in both formulas, and then I'm going to calculate what the corresponding y will be. So, but I do this separately for both formulas. So, I'm going to fill in x is equal to 5. This means I'm going to replace my x by 5, and please remember we multiply between the 2 and the x, so we will get this. Y is equal to 2 times 5 minus 7. Well, if we've done this correctly, the answer should be 3, because what x is 5, there really should be a y that's equal to 3. Well, let us check that. 2 times 5 is 10, minus 7, and that's 3. So this one's correct. We're going to do this also with the other formula, and we're also going to fill in x is 5. And I'm going to use the second formula, minus 3 times 5 plus 18. And again, we see minus 3 times 5 is minus 15 plus 18, and that's also 3. So this means that this point really belongs to both formulas. Only that one, because those two lines are really different. They have not one point in common except for this one. So they are, at this point, they are equal. And that's a really important word in this section. They are equal over here, not over there or here. Only here they are equal. So maybe when you think about this, this is a lot of work to find the point of intersection of two graphs. First you have to make those tables, then you have to plot the coordinate system, and then you have to read off the point of intersection. And this is really easy to read off, but that will not always be the case. So we're also going to learn how you can calculate this point of intersection. This is what we saw until now. We do know the point of intersection, the coordinates. I have those both formulas. And again, I told you, they have nothing in common. Only the point of intersection. And that's what we're going to use. Again, they are different, but they are equal over here. And there's that word equal again. So how do I calculate this point of intersection? I'm going to equalize the formulas. This means I'm going to write down 2x minus 7 is equal to minus 3x plus 18. And when I do this, you see, I'll have an equation. This is an equation. So that's what we're going to learn in next class. What you do first is we equalize the formulas. And then we have an equation, or we can solve an equation, because there's only one variable, the x. So when I solve this equation, I can find the x-coordinate of the point of intersection. And when I do find the x, I can use one or both formulas to calculate the y-coordinate. So this is what we're going to do in next class. But for now, you need to be able to draw the graphs of two formulas. You need to plot them together in one coordinate system, and you're going to read off the coordinates of the point of intersection. And then you are going to check them, just the same way as I just shown you. Okay, good luck. See you next time.